Hey, Math 30-2. So today or not today, in this lesson, we are going to talk about the C's and the D's of this sine graph. So we determine A determines like this amplitude of the graph, B changes the period of this graph, and C and D is going to do, well, we already talked about D before, it changes the midline, and C changes how much it moves side to side. We saw that at the very first lesson of these graphs, where we did Desmos and stuff. Now, I'm not going to talk too much about the D value too much because the D value is the midline. That's just, it says it right in the notes down there. It's the C value that gets a little bit tricky. Now, most of these questions in here just talk about, is there a horizontal phase shift? But later on, we talk about what is the horizontal phase shift. We want to figure out how do we calculate that. Not necessarily which way it's shifting. I'm not too concerned if it's moving left or right. I just want to know what is the value of the shift. I'm not going to be too concerned. Can you figure out which way it's going? Remember what I said before? If it's greater than zero, it's going like the opposite direction what you think it would be. So if you want to put in left and right, you can. I might write the left and right parts in there. But really, all you have to do is determine how much does it shift by. Now, what I have written here in the where the C is related to the horizontal shift, if there is a C value, then there is a shift. If there's no C value, if it's just like Bx and there's nothing there afterwards, then there's no horizontal shift. Okay, makes sense. Now to find the horizontal shift, you go C divided by B. And we could see how that kind of works here. So here's my graph here. I kind of zoomed into it. You can see I have half a graph shown here. It goes to 180. If I go a little bit more over to the side over there, it'd be going to 360. Now, I'm not going to change the B value right now. What I'm going to do is I'm going to show what happens when I change the C value. So Bx plus C is all inside the sine here. So if I increase that up, so my C value is positive 80 and plus 80, you can see that I moved over 80 degrees. But I moved over to the left. The graph has moved to the left. If I go negative, it's moved over to the right. So you can see that starts over here, there at the x-axis at the origin there. As I make it negative, the whole graph starts moving over. There. I'm moving over by tens here too. Okay. Now, if I change the B value, so let's just change the B value to this one here. So I'm just going to get rid of the original green graph. So if the B value is changed to a 2, remember what happened there is the new period of the graph is going to be the original period, which is 360 divided by this. So now it's 180. So you can see a whole graph now going up to 180. Now, if I move this over, so my C value becomes 10, a lot of people will say, oh, it's just going to move over by 10. If I do this, it actually only moved over by 5. So you went from, I go from 10 here, from 90 to 85. Go to 20, oh, now it went to 180. So let me put the graph in here again. So this is the original graph. I just put a 2 there to make it the same. You can see that my C value is 20, but I've only moved over 10. If I go 40, I've only moved over 20, right? And it's in the opposite of the negative direction here. So if I go 30, sorry, negative 60, I've only moved over 30. 1, 2, 3, so 30. Okay. So if my B value is 3, let's change my B value to 3 here. Same thing happens. So let's go to it's 0, so there's nothing there. So what if I go 30? So if I go 30, oh, I've only moved over 10 because what I'm doing here is I'm taking the C and I'm dividing by the 3. So 30 divided by 3 is 10. So I've only moved over 10. So if I go to 60, I've only moved over 20. If I go to 90, I've only moved over 30 because I'm dividing these two. I'm not doing the other ones because they're harder to see the changes. I'm just doing the nice even ones. So 120 divided by this, that's 40. Yeah, the difference between these two is 40. So my shift is C divided by B. Also works the other way too. It's a bit harder to see this, but my B value is a half, 0.5, so there's my original graph. Let's put my C value here. Okay, so they're right on top of each other. Now, let's say I'm going to go try and move it this way. So I'm going to put a negative number here. If I put negative 10, it's actually moved 20. But negative 20 is moved 40. So it's moving twice as much as it was before because I'm taking 30. Let's say in this case, because it moved 60 here. I'm taking 30 divided by half. And 30 divided by half is 30 times 2. So it ends up being 60. So my shift is C over B. If it's a positive number, it turns left. If it's negative, it goes right. The midline is if it's positive, it goes up. If it's negative, it goes down. Now the domain, very key here, the domain of all these kind of graphs we talked about, unless we go to like word equations, which we will do, is just XER unless otherwise we state it. Now the min and the max, if you don't have a graph and you don't want to graph it on a calculator because nothing stops you from doing that, and you can find the min and max from the calculator that way, you can think about the graph this way. You find out where the midline is. So here's my X and Y axis, right? Find out where the midline is. So the midline would be where D is. Remember, that's what the midline is. The midline is the D value. Okay, so let's imagine the D value is right here. It could be negative or positive, but let's just say the D value here is positive. So this line is Y is equal to D. So that's my D line, my midline. And the graph is going to go up and down from there. So the minimum point of this graph is from the D value, and I'm going to subtract A. I'm going to go down A from whatever this value is. So that's what this min value is saying. It's going from the midline minus my amplitude. And the amplitude, remember, is always a positive number. So you just go to, the amplitude is 5. You take whatever number this happens to be. Let's say it's 2. And then minus, okay, let's say it's 3. Right? Or add to go to the top, the maximum value. So the midline stays the same, it's just my midline. And I'm going to add or subtract the amplitude to get that. We're going to see that a couple times when we look at some of these examples. What is, like here, what is my period? What's my domain and range of these functions? Or just what's the range of these functions? So we're going to see that a couple times in some examples here. Now to see the horizontal, if there is a horizontal phase shift, you draw the midline and then you see whether or not the graph is going up through that midline. If it's not going up through the midline, there's a shift. If it is going up through the midline at the y-axis, then there is not a phase shift. Okay, we'll see that as I go down. Okay, so the first thing you want to do when you do this is you always want to draw a midline anyway. So let's first of all, let's draw the midline for this graph here. So my midline for this graph is right here. Okay, so that crosses at -2. Y is equal to -2. I'm going to put it as an equation of a midline. Okay? Now you notice that my graph right now through the midline, through the x-axis, plus it's also a little bit higher, is going down words through this. Now, an original sine graph before any shifting side to side is going up through the x-axis, right? So up through the midline. So if you could just say this is my midline, right? It's going up here through the y-axis and the midline. Where they intersect each other, it's going upwards. You hear it say it's going downwards. So there has been a phase shift because it's not doing what it was originally doing, going upwards through the midline. Right? So there's definitely a phase shift in this one. This one here, you can see it also. There's my midline. They're not even on the same spot. This is actually up here, it's going downwards, but they're not even close to each other. The original sine graph, the midline, and the y-axis, the graph is going right through the two. That's the original graph. It's going up and down from there. So if they don't intersect each other, like the midline and the graph don't intersect each other at that point, then there's definitely been a shift. My midline here is 2, 4, 6. So y is equal to 6. I don't know what just happened. Things just kind of froze up on me. Oh, there we go. 6. Yeah, things like talking like crazy on me. Cool. Okay. Let's go down here. Let's see. So my midline. Here's my midline. It's going right down the middle. So that's right down y is equal to 0. And they're not touching each other, and it's also going downwards. So that's two wrongs here. So there's definitely been a phase shift to this one. So let's look at the midline for this one here. So the midline looks like, you're going to kind of eyeball this one. It looks like this is where the midline is. So y is equal to 246 again. And again, it's going downwards. So there's definitely being a phase shift here. You notice I'm not trying to find the phase shift. I just want to know if there is a phase shift. That's all I'm really concerned about for this right now. And here's my next one here. My midline, I don't know why I drew it kind of weird here. My y is equal to 1. But look at this. Okay, so this one is actually going up through the midline and the y-axis at the exact same time. So this is good. So that means there is no phase shift to this one. All the graph is just moved upwards. And it's kind of stretched a little bit. Actually, it hasn't stretched. Yeah, it has. No, it hasn't. The period is 2 pi still. So it's still the same period. The amplitude is a little bit more though, but it's starting at the same spot. Okay, let's see this one. Where's the midline? Y is equal to -1, so that's my d value. It's going to be negative this time. That's fine. And they're not even close to each other here. Right? You want it to be going this way. Obviously, it's not doing that right now. So there is definitely a phase shift here. Okay, midline here. It's pretty good. Oh, look at that. That's nice. The y-axis, the midline, and this thing's going upwards. Yeah, so there's no phase shift there. So it's the direction it should be going. And this is 5, 10, 15, 20, -20. There you go. Yeah, definitely a phase shift. I can see that right away. If I get that line. They're not even close. They're not touching each other. They're pretty close, but they're not touching each other. It's also going down. My midline is right down the x-axis. So y is equal to 0. Looking pretty good. So I got to determine where should I stop this video? Where have we talked so far? Yeah, okay. So I'm going to stop this video at this point here, and we'll come back to this one part, the next part. Okay? I'll see you in the next video.